Welcome to our presentation. Today we are very happy to show you our project, the automatic bit feeder. We made this project for our computer-aided drawing class with our teacher, Dr. Sukhairi. First, let me introduce you to our team. We are a team of two members. We have Ahmed Salim Bagais, who is our team leader and the electronic designer. And my name is Abdullah Ismail Sahmani, and I'm the mechanical designer. We worked very closely together to bring this idea to life, and we hope you like it. First, let's talk about the problem statement. Let's start with the main problem. Why did we choose this project? Today, many bit owners are very busy with their lives. They work long hours or sometimes they get stuck in traffic. Because of this, it's very hard for them to feed their bits at the exact same time every day. If you only feed your pet by hand, you might forget a meal, give too much food by mistake, or give too little. This is very bad for the pet's health and makes the owner feel worried. The solution is a smart automatic machine. This machine will do the job for you. It will drop the right amount of food at the exact right time every single day, so you never have to worry. To make this solution happen, we set four main goals for our project. First, we wanted to build a working 3D model of a feeder that is the perfect size for small pets, like cats or small dogs. Second, for the mechanical design we used a powerful program called Autodesk Inventor to draw the machine and all its moving parts. Third, for the electronics, we designed a custom electronic board using Circuit Maker. Fourth, for the automation part, we used a smart timer and a small computer brain. This makes sure the food drops exactly on schedule without any mistakes. How did we do? How did we build this? We followed four simple and organized steps to make sure we don't make mistakes. Step 1 was planning. We used Canva to think about our idea, draw them, and agree on the final shape. Step 2 was the 3D design. We used Autodesk Inventor to carefully build the 3D parts on the computer. Step 3 was electronics. We used Circuit Maker to design the wires and the smart board. Finally, step 4 was writing. We used MS Word to type our final report and document everything we did. Next, let's look at the physical parts of the machine. We wanted to design to be safe for food, easy to clean, and very simple to build. The machine has a big plastic box at the top to hold the dry food safely. We choose plastic because it's light and strong. At the bottom, there is a small spinning nylon gate that drops the food smoothly. We use strong plastic pieces to connect the motor to this gate, so it moves perfectly. Finally, the food falls into a stainless steel bowl. We choose stainless steel because it's very safe for pets. It does not keep bad smells and it's very easy to wash. On this last slide, you can see the final 3D picture of our complete design. We are showing you three different views so you can see every detail. The front view, the side view, the top view. These pictures clearly show how all the small parts come together beautifully to make the final bit feeder. It looks neat and does not take up too much space. That is all for my part of the presentation now. Now I will leave you with my friend and partner Ahmed to explain the other part of the project. Thank you.
Hello and good evening. My name is Ahmed Bagais and I will continue for the electronic part of our mini project. Moving on to the electronic architecture of our automatic bit feeder, I will now walk you through our electronic control system. The brain of our project is the ATmega 328P microcontroller. We selected this specific chip because it efficiently handles three core tasks. It executes the primary system logic, it constantly monitors the time, and it generates the precise PWM or pulse width modulation signals required to control the servo motor. To ensure our feeding schedule remains strictly accurate, we integrated a DC3231 RTC. This is a highly accurate real-time clock that manages our schedule. It communicates seamlessly with the microcontroller using the I2C protocol. Finally, for power management, we utilized an LM7805 voltage regulator. Our system is designed to receive an external 12 voltage supply, and the LM7805 safely steps this down, converting it to a stable 5-volt output to protect our logic components. Let's look at how these individual components interface with one another on the board. Starting with the power, the board receives its 7 to 12 volt input through a dedicated VN header. For data transmission, the I2C lines, specifically the SDA and SCL pins, form the critical connection between our RTC module and the main microcontroller unit. When the time matches the user's feeding schedule, the microcontroller sends a signal out through a dedicated PWM pin. This pin triggers the servo connector, which will physically open the feeding gate. Additionally, you will notice decoupling capacitors in our interfacing strategy. These are crucial for noise filtering, ensuring that electrical interference from the motor does not disrupt the microcontroller's logic. Here you can see the complete electronic schematic that maps out these interfaces. It details the precise wiring between the AT-MEGA328P, the RTC DC3231, and the LM7805 regulator, alongside the headers for power and the servo motor. This schematic served as our blueprint for the physical board. Once the schematic was verified, we moved into the PCB design phase. The layout was prepared using Circuit Maker, and we made sure to strictly follow standard engineering design rules throughout the process. First, we optimized all our trace lengths. Keeping traces directly is vital for maintaining signal integrity across the board. Second, we focus on balanced component placement. This ensures we meet necessary safety spacing requirements and keeps the board organized. Lastly, as I mentioned in the interfacing section, decoupling capacitors were placed strategically. On the layout, they are located near the power pins to maximize their ability to filter out noise. That's it for our mini project. Thank you for your time and goodbye.